subtract the exponents for the x's. You should have an x remaining on top because the power 2 minus 1 leaves you with an x. The largest power is on the top. For the y's, the larger power is on the bottom. Again, 2 minus 1 leaves us with 1y. And then 16 81st, there's nothing in common there, so it's just going to stay as 16 and 81. So reducing the x term, the y terms, the x should be on the top, the y is on the bottom. Looking at the next one, doing exactly the same thing. So here's the x's. The larger power is on the top. 3 minus 2 is 1. Doing the same exact thing with the y's. Larger power is on the top. 3 minus 1 leaves us with 2. And then 54 over 24. They're both divisible by 6. So what does that become then, Cooper? 9 over 4. Okay, so we've reduced both pieces. If you multiply across the top and across the bottom, does anybody know what 16 times 9 is? 144. And then adding your x's, so x and another x makes x squared. There was already a y squared. Cooper, 81 times 4? Makes 324, and then there's a y. So multiplying across the top, across the bottom. And then the last thing you have to do is simplify one final time. So simplify a piece, simplify a piece, simplify the whole. So Cooper, I think you had this. 144 over 324 reduces to? Yeah, reduces to 4 over 9. And then what happens with the y's, Cooper? Yeah, it's just going to be a y on top. So the x squared is on the top. There isn't another x to combine. But when you combine the y's, you just get a y on top. Any questions with number 12? Because there was a lot as I was walking around.
Could you simplify by doing it diagonal with each other?
Yep, you can do that as well. Sure. Yeah. Yeah, did you guess?
X squared y over 9.
Are there other questions on the worksheet that you wanted to go over? Audrey? 16? Okay, so if you take a peek at number 16, ladies and gentlemen, way too much talking, please. Number 16, again, it says division, so you need to change it to multiplication. When you change it to multiplication, if you can factor in the same step, then you might as well save yourself a little bit of writing. So let's factor the left side first. So we have x cubed plus 4x. What would they have in common that we could take out? Chelsea? An x. So that leaves us with x squared plus 4. The bottom says 2x minus 1. So that's not changing because it can't be factored. It's just 2x minus 1. This second piece flips. So the top is now x squared minus 4x minus 12. Audrey, how would that factor?
I said x minus 6 and x plus 2.
That's perfect. X minus 6, x plus 2. So now that's on the top. And then the bottom is x squared minus 16. Brandon, how does x squared minus 16 factor?
X squared plus 4, x squared minus 4.
Right, x squared plus 4, and then x squared minus 4. So if you just look to see what you have right now, there is one piece that can cancel, Brandon, and that one piece that can cancel is?
X squared plus 4.
X squared plus 4. So that piece can cancel. X squared plus 4, x squared plus 4. So we still have an x with a 2x minus 1. There's a times sign. There's an x minus 6, an x plus 2. And then on the bottom is still this x squared minus 4. Brandon, can that factor any further?
Yes, x plus 2 times x minus 2.
Right, so this is a difference of perfect squares. So it factors one more time to x plus 2 and x minus 2. So it started out as x to the 4th minus 16. Perfect squares. So x squared times x squared makes x to the 4th. 4 times 4 makes 16. So we have that plus or minus. Well, the plus part cancels because that piece was already in there. But the x squared minus 4 gets factored one final time. So then when you're looking canceling the piece out that's in common, now we can cancel out that x plus 2. So on the top, there's an x and an x minus 6. On the bottom, there's a 2x minus 1 and an x minus 2. And if you'll notice on the answer key, none of them are FOILed back together. Everything is left in factored form. So if you're factoring it to break it down, there's no point to refoil it back together. It's actually considered simplified if it's factored. So simplified form is factored form because anything that's broken down all the way is something that's already in factored form. So this would be your answer, the x minus 6, and then the 2x minus 1, x minus 2. Questions? So today we're going to talk about the least common multiple, which leads us into tomorrow working with least common denominators so we can add and subtract fractions together. Because if you have two fractions, the only way you can add them or subtract them is if they have the same denominator. And in order to do that, we have to be able to find the least common denominator or the least common multiple. Tomorrow you will have a short 3-question quiz. 1 question on simplifying, 1 question on multiplying, 1 question on dividing. So 5 minutes, 3 questions. And you'll be given it right at the beginning of class, just like the factoring quiz. So I'll walk around and check your homework as you're working on that. And again, it's just a short 5-minute quiz. Your tests are graded. They are in the grade book, so you can feel free to check them. I still have a good list over there, so until a good number of them are made up, I'm hoping tomorrow I can get them back to you. And then there was an assignment. I think a lot of you noticed that there was an assignment that you got like a 4 out of 10 on. That's been fixed, so that was my fault. I just didn't, the grade book just automatically puts it out of 10, and I didn't change that. So that's like its default. Everything is out of 10. So that's why if you had a 4 out of 10 and you noticed your grade bumped down a little bit, that was why. It was just my fault. All right, so if you look at the little sheet that you picked up when you came in, I'm going to send a hole punch around just in case you want to hole punch yours, maybe. Brandon, is the hole punch next to you? Yes. How about you just pass that around in case anybody wants to hole punch it? The first couple of questions here want you to list the 10 different multiples of 12, or the first 10 multiples of 12. That would be another way of saying it. List the first 10 multiples of 8. And then part 3 says, take a look at each of them, circle the numbers that are in common to both. So see if you can do that. List the first group of 12, the first 10 of multiples of 8.
This reminds me of 5th grade math.
Good.
I forget her name.
It's okay.
Cause I didn't have her as like my main teacher. She was just like my math teacher.
Mhm.
What's her name? Miss Lamarck. That was mine. And you said
I remember Miss Lamarck. I
Who's
hated her.
the other Miss?
Snyder.
Myers. Myers. That was my math.
I know what I'm talking about.
All right, so what are the first 10 multiples of 12, Ethan?
Oh, 12, 24. We're gonna go with 36. We're gonna go with 48. Then after that, we're gonna go with 60, and then 72, and then 84, and then 96, and then 108, and then 100, or no, 112, 120, 120.
Okay,
And then-
so that's it. You're good. You got 10.
132.
Okay, so Luke, how about the multiples of 8?
What?
Multiples of 8.
8, 16,
4, 32, and 40, and then 48, and then 56, and then 64, and then 72, and then 80.
All right, so the second part, or I guess the third part, says to look at each of your responses, circle the numbers that are the same in both. What's the first number that's the same? Brandon? 24. So 24 is the first number that's the same. The second one that's the same is
72.
48.
6 times 8 equals
And then the last one that's the same would be the 72. So 24, 48, 72. Each one of those pairs would be common to both. Well, it says just the first 10. Okay, so the last part says out of these numbers that you circled, the smallest one would be 24. 24 is called your least common multiple. So a multiple is a number common to both, two different values, that they both divide into. So a greatest common factor is different than a least common multiple because a factor is breaking a number down. That's what factoring means. Take a problem, break it down, simplify it. Whereas a multiple is a larger number that two values will divide into. So the first number that 12 and 8 divide into is 24. So the least common multiple, multiple means multiply. That's why the number's bigger. Factor means like break down, reduce. So when you find out the greatest common factor, you're finding a number that divides into two things. When you're finding a multiple, you're finding one number that those two values will divide into. So it's generally a bigger number. In the little box, it says the least common multiple is referred to also as the least common denominator, or the LCD. So when it's in a fraction, it's the least common denominator. If it's not as a fraction, then it's called the least common multiple. It's defined as being the smallest of the common or similar multiples of two numbers, two terms, or two expressions. So it doesn't just have to be numbers. It can be terms, that means they have like an x, a y, a z. It could be an expression, something that would be like x squared plus 2x plus 1. So we'll be looking at trying to find least common multiples for both. In the example right next to it, this is like, I should have changed these numbers, so we'll just cross them off. And let's use, how about 5 and 18? That sounds a little more interesting.
It's just such an
So, think about the number 5. Do it the same exact way. So, list the powers of 5 or the multiples of 5.
Those are easy.
16.
There's 12 and 8. But how many can?
I'm just listing a bunch.
Okay.
I'm going to go up to 100. There we go.
Oh my goodness.
Okay, so those will be all the multiples of 5 up to 100. If we do the same thing with 18, we would have 18, 36, 54, 72, and 90. So the least common multiple, the first number that they have in common, that they're both going to, would be 90. So least common multiple is the first number that two values divide into. And in this case, with 5 and 18, it would be 90.
I was wondering why we had to find that last night.
Why you had, yes.
Yeah, I
So
was wondering why it was a problem.
your homework last night, the problems in the book were given so that you can kind of start thinking about that least common multiple concept again. So we are going to look at least common multiples with expressions and terms, not just numbers. And there is a way to kind of think about getting a least common multiple. The first step says to factor. Essentially, everything we do in the rest of chapter 8 involves factoring. And we're going to be factoring first and not factoring last. So problems need to be factored so that you can simplify them, so that you can break them down. So if we're finding a least common multiple, step 1 would be to factor. The second step says compare the individual factors in each of the polynomials. So we're going to have two expressions that we're comparing those factors. If common factors are missing, then insert them into the least common multiple of the two polynomials. So So in the back, we have some examples that we're going to work through to see if we can try and figure out least common multiples, so that tomorrow you already know how to do this step, and then the adding and subtracting would be the part that we add to it. So at the top, it starts out easy, and we just kind of build on the expressions that you're given. So for example 1, find the least common multiple of 3x and 3x minus 6.
It's a thing.
The first step is to factor. So if we have 3x versus 3x minus 6. 3x cannot be factored because it doesn't have an addition or a subtraction sign, so it's just staying as 3 times x. Like 3 is a factor, x is a factor, but there's no way to factor it. How do you factor 3x minus 6? Chelsea?
You can pull 3 out, so it'd be x minus 2.
Right, so you can pull a 3 out, and then you get x minus 2. So now both of them are factored. That's the first step. The second step says start by writing the factors of the one on the left. So to get your least common multiple, you're going to start by taking the first piece on the left and writing that down, because all of that has to be part of the least common multiple. So the 3 and the x. Compare with the factors on the right. So if you look at the right has a 3. If there's already a 3 in your least common multiple, then I don't want to write that 3 down again, because they share that. They have that piece in common. So if they have a factor in common, it's already part of the least common multiple, the least common denominator. You don't want to write it again. The next part up here on the right is x minus 2. Well, if it's not in the least common multiple, then it needs to be included in it, because it's a different factor. It's a piece that's missing. There's nothing left, it's just the x minus 2, so that means your least common multiple is the 3, the x, and the x minus 2. So the 3x comes from the first piece. You're not putting another 3 in there because there's already a 3 down there. So that part they're like sharing, that's the part they have in common. We have an x from the first piece, and then the second piece, the part that was different was the x minus 2. That's like your missing factor. So the least common multiple, least common denominator would be 3x times x minus 2. Don't FOIL it. Don't distribute it. Leave it as factored for. Questions? Ethan?
Why is it 3x?
Because the first, say again?
I thought you got rid of the 3.
We're not getting rid of the 3. We're just like they share that part in common. It still has to be part of the least common multiple. So they share the 3. We're not really getting rid of it, but we're saying they both have that in common. I don't want to add an extra 3 to it. All right, so looking at example 2, find the least common multiple of x squared plus x minus 2 and x minus 1 quantity squared. So step 1, these are not factored completely, so therefore we have to factor it first. So looking at x squared plus x minus 1, and then x minus 1 squared. Oh, thanks. Thank you, Brandon. Minus 2. All right, so how does x squared plus x minus 2 factor? Ethan?
X plus 2 times x minus 1.
Right. So that's just your standard factoring. You're using the two multiples that give you -2, but add to be +1. The second one, if it's a quantity squared, what does that really mean when you have a quantity squared? There's 2 of them. So really we have an x minus 1 and an x minus 1. So if it's squared, it really means that it's there twice. If it's cubed, it means it would be there 3 times. Step 2, start by writing the factors of the one on the left side. So the expression on the left, both of those pieces creates the least common multiple. So we have an x plus 2 and an x minus 1. So whatever's on the left must be part of the least common denominator, the least common multiple. Then it says compare with the factors on the right. So if you look at the right side, the first one says x minus 1. I'm going to cancel that out because they already share an x minus 1. So if it's already in there, if they already share it, we don't need to write it again. However, there's another x minus 1. That second x minus 1 is not part of the least common multiple. That's the piece that doesn't have, like that it doesn't have or that's missing. So we need to add a second x minus 1. So one of them they share, you can think of them as overlapping, that part's the same. But the parts that is different is another x minus 1. And anything different from the first needs to be added or inserted as part of the least common multiple.
Can you just make it x minus 1 squared?
You could then just make it x plus 2 and x minus 1 squared. Or you could keep it separate if you'd rather have it separate. Questions? So you're factoring it, you're taking the multiples from the first, looking at them the second, and seeing what it's missing. Whatever it's missing needs to be then added to the least common multiple. So example 3. Find the least common multiple of 9x squared minus 16 and 3x squared minus 2x minus 8. Again, these are not factored, so you need to factor it first. How could we factor 9x squared minus 16? Brandon?
3x plus 4, 3x minus 4.
Right, so this is a difference of two squares, 3x plus 4, 3x minus 4. So 9 and 16 are both perfect squares. It's a difference, so we factor it with the difference of two squares. 3x squared minus 2x minus 8 is the AC grouping. So this you have to go through the couple of steps to get it to work, to break it down completely. Libby, what two numbers multiply to be negative 24 but add to be negative 2?
Negative 6.
Yep, negative 6 and 4. So 3x squared minus 6x plus 4x minus 8. Take out what the first pair has in common, that's a 3x. Take out what the second pair has in common, which is a 4. And then rewrite it 3x plus 4, x minus 2. Jeez, I can't write today, apparently. So once it's factored, to get your least common multiple, you're writing the factors that are on the left. Well, the factors on the left are 3x plus 4 and 3x minus 4. Looking at the factors on the right, anything that's missing or that's not already down in your least common multiple also needs to be added to that or inserted into the least common multiple. So the 3x plus 4 is already there. They share that. That's the common piece. That would be their greatest common factor. That's the piece they have in common. But the part that's different is the x minus 2. So my least common multiple will be 3x plus 4, 3x minus 4, and the x minus 2. Questions? So there is one last problem, but I'd like you to add a second. So if you want to cut like the page, that space in half, or put it on like the side of your paper.
I'm cutting it down.
Not literally, but I put a line
Oh,
down,
yeah,
right?
definitely.
Yeah. You're not literally cutting it in half. So
That'd be weird.
Weird. It'd be like,
Snip, snip.
the first problem doesn't need factored. So if we're looking at 15x squared y squared z cubed, 25xy to the 4th, do we need to factor that? No, there's not a plus or a minus sign, so it doesn't get factored. So then you have to start with the numbers. So 15 and 25. We need the first number that 15 and 25 go into. 75. So if you're not sure, think about the multiples. So 15, 30, 45, 60, 75, 90. That would be the first group. For 25, we would have 25, 50, 75. So if you're not sure, you can write out the multiples. Once you get to that first value, you're done. You can stop. So they both have 75 as their least common multiple for 15 and 25. So that's where we would start. So when it has a number in it, you got to think about it a little differently. So then the second step would be to take everything from the left. Well, that would be all of these pieces here. So we have an x squared, a y squared, a z squared, cubed. So look at the number separate, look at the pieces after it. Then compare it to the other term, that 25xy to the fourth. What's different? What extra parts does the second one have that the first does not? Isabella? It has a y to the fourth. So Isabella, how many extra y's does it need if our first one has y squared? It needs a y squared. So I'm not adding 4 y's or y to the fourth, we're adding the extra pieces that it needs. There's already 2, it needs 2 more to get to the y to the fourth. So then our least common multiple is 75x squared y to the fourth and then z cubed.
Hopefully you do it.
Questions with that? So why don't you try the extra one that I added here. Just add that somewhere on the bottom of your page, side of your page, see if you can factor it. And then try and think of the same process. Like if there's a number involved, you've got to think of the number first.
What wants to be
This is a short one.
So what goes into 18x squared minus 36? What's the GCF? How could we factor that? Chelsea?
You can pull out an 18x.
Great. We can pull out an 18x and you get x minus 2. And then Chelsea, the 15x cubed minus 30x squared you can pull out
A 15x.
a 15x, and then you also have
X minus 2.
x minus 2. Okay, so the tricky part then is thinking of the numbers 18 and 15. We need the first value that both 18 and 15 divide into. 90. So if you don't know that, write out your the values again. So start with 18, 36, 48, just keep going, or 54. We'll keep working through them until you get to that matching point. But 90 would be the first number that 18 and 15 both divide into. So again, if you're not sure, write out the multiples until you get that value that they meet. So then you start with the left. The left has an x and it has an x minus 2. What extra piece does the right have that the left doesn't have, Scott? It has an extra x because there's 2 of them. So that means this x needs to become x squared. So the first one has 1, this second one has 2 of them. So it's missing an extra x value. So it needs to be an x squared. So you're not multiplying the powers together to make it x cubed. You're just adding whatever's missing from the first and placing that in the least common multiple. So the worksheet that I have passed out to